Okay, Algebra 1 students, in this video today, we're going to finish up our studies of the word problems in Chapter 2. So please copy down your heading for today. Your heading is Chapter 2, Word Problems, Part 2. Be sure and include today's date, if you would, please. Be sure and include today's date, and here we go. Now, okay, students, I don't have a lot to say, okay? You know that we're going to work on word problems that review what was taught in Chapter 2. So let's jump right into these and get them done, okay? We're going to look at 2 word problems. They are pretty easy. Sorry about that there. They are pretty easy, as are the homework problems also, okay? But let's work hard and let's finish these word problems well, okay? We're looking at 2 word problems. I would strongly encourage you to not copy down this entire word problem, but instead write in your notes page 88. I'm not sure where all these typos are coming from. Page 88, example 4. Okay? Alright, here we go. Sorry for yawning. You can turn over in your books to this page. Let's get started. You own 2 stores that sell household appliances. The matrices below show revenue and expenses for 3 months. So, store 1 had this much total money come in January, February, and March. Okay? Store 2 had this much money come in January, February, and March. Okay? Now that's not their profit, that's the total money that came in. They have expenses. So here's the expenses over here. Okay? Here's the expenses for each month, store 1. Here's the expenses for store 2 for 3 months. Okay, now think about it, guys. Stop and think. If you made $20 for mowing a lawn, but you spent $1 in gas to mow the lawn, then you would subtract out $1 because this is your expenses, this is your revenue, total money that came in, and your profit would be $19. Correct? You take your total money minus your expenses, and you're left with your profit. Got it? Okay, let's read letter A. Write a matrix that shows the monthly profit for each store. So students, think about it. All we have to do is take our revenue matrix minus our expense matrix, and the matrix we'll get out will be a nice profit matrix, okay, for store 1 and store 2 for January, February, and March. Guys, think about it. Here's your profit for store 1 in January. Here's your expenses. Subtract those 2. And right here, you'll have your profit. So, to save time, because I know all of you know how to add and subtract, I went ahead and did the work. Okay, so hold on 1 second here. While I copy this down for you. Okay, so you would get 19,006 here. You would get 18,157 here. You would get 8,855 here. 10,886 here. 15,457 here. And look at this. Here you would get a negative 2,051. So store 2 in the month of March actually lost money. Their revenue was less than their expenses, or you could say their expenses were more than the money that came in. Okay? So there it is. Very simple, not too difficult. Now, on to question B. Which store had the higher overall profit? Okay, well, let's see. Actually, guys, And it's pretty obvious. Look at store 1. If you add all those up, you're going to get around 45,000. Okay? Over here, you got 25 minus 2. You're getting around, I'm estimating, you're getting around 23,000. So which store had the higher overall profits? Store 1 did. Add up all their profits for January, February, and March. Okay? And lastly, which store lost money? Right there it is. Store 2. What month did they lose money? In March. Store 2 lost money in the month of March. Okay? Alright, back this up and watch this again if you need to, okay? Alright, moving on to our next example. Okay, students, I'm not sure why I don't have the page number here, but it's page 95. Okay, so in your notes, I would write page 95, example number 4. You're welcome to write this problem down in your notes, but you don't have to, okay? Here we go. A flying squirrel descends from a tree. So here's the ground. Here's the tree. Here's the squirrel coming out, okay? Right here. It's going downward with a velocity of 6 feet per second. Now it's negative because we're dealing with velocity. Remember, velocity is either positive or negative depending on whether it's going up or going down, okay? We're going down, so that's velocity negative, okay? Find its vertical displacement in 3.5 seconds. Now, guys, the math part is easy. It's going down 6 feet every second. And it does that for 3.5 seconds. So, for 3 seconds, think about it, guys. 6 feet for 3 seconds, that's 18 feet, okay? Then, a half a second would be half of this. That's 3 more feet. So, 21 feet. Now, listen to me carefully. Distance is always what? Positive. But displacement is positive or negative, again, depending on whether you're going down or up. So the displacement is negative 21 feet because the squirrel dropped from here to here 21 feet. Now, another way to do that is to simply take your rate, which is 6 feet per second, times the seconds. Okay? So, the squirrel is dropping 6 feet every second for 3.5 seconds. Multiply 1 decimal place, go over 1, and you get 21. Of course, it's negative 21 feet because it's displacement. So, the couple of things I wanted you to learn from this video is how to use matrices in word problem situations. And here, I want you to remember that, yes, distance is always positive, but displacement can be either positive or negative, depending upon whether you went down or up. Okay? Alright, guys, that's it for today. I hope this video has been a help. If you have any questions at all, please don't hesitate to contact